We're going to get started right now. So welcome everyone to our virtual Teen Science Cafe. It's really exciting that we have the opportunity to continue doing our cafes in person and still online. And my stuff is not working.
I can see your screen.
Yeah, it's apologies. Hang on 1 second. It was working perfectly 2 seconds ago. Thank you all. It's been a while, technical difficulties. There we go. Okay. All right. So what we like to do when we are here in our virtual cafes, I'd love it if everyone could open up your chat and just let us know who you are and where you're coming from. I'm also going to pop into the chat. We do have the option for captioning. If you need our captioning services, I just put a link in the chat. You can click on that and get our closed captioning, but would love it if you put your name in the chat, where you from. It's always just fun to get an idea of who's joining us tonight. And while you are doing that, because again, let us know who's with us. Just want to go over when we do our virtual cafes here in Zoom. First of all, we'd like to have you put your correct name. So to do that, you would go to the participant list and rename yourself, making sure that it is you, because sometimes you come in maybe under a parent's name or a sibling's name, and we want to know it's you. So hi, Cosimo from Wheelock, Vermont. Thank you so much for telling us that you're here. So keep doing that. And for the rest of you, I'm just going to keep going on. So keep introducing yourselves in the chat, but I'm just going to move on that when we're here in Zoom in our cafes, we ask that you stay muted unless you want to ask a question. And you're more than welcome to raise your hand, and you can do that using the raise your hand feature, and we'll call on you and you can unmute yourself to ask your question, or you can put your question in the chat box. The chat box is meant to be a way to communicate back and forth with our presenter if you have a comment or a question related to the topic. And again, the chat box is really to stay on topic. So we ask that you be courteous and respectful, keep everything appropriate, and just really engage with our presenter tonight. We have a fabulous topic that you're going to learn all about tonight. And just so you know, you do not have to have your video on if you don't want to. That's your choice. And I see that Andrew from Essex is joining us, and Camille is here as well. So welcome, everyone. So let me introduce tonight's presenter. You're going to learn about precision agriculture and social ecological gaming and simulation with Scott Merrill. Scott is a research associate professor in the Department of Plant and Soil Science, a Gund Fellow at the Gund Institute for Environment, and he's also the managing director of the Social-Ecological Gaming and Simulation, also known as SEGS laboratory. He is a quantitative systems ecologist, and his research spans a wide range of both natural ecosystems and social ecological systems. His current work includes developing tools for precision agriculture, flood hazard mitigation, food security, animal health, and climate change. And he is also going to be one of our lead faculty for one of our summer academies for the Agritech Innovation Program. So let's welcome Scott. And we are so excited to learn from you tonight.
Oh, thank you. That was a very nice introduction. I'm joined as well by my co-presenter, Alex Fredrickson. Alex comes to us, just graduated from the University of Vermont, and now is getting his master's degree in complex systems and data science. Is one of our lead software developers for the SEGS lab, which means he does everything that can be done on a computer, basically. He's working on problems with developing maps for the Precision Ag project, which is why he's here, but he's also doing some of the flood work with us and developing some games and simulations. So thanks for joining us, Alex. Is there anything else you wanted to add?
I think you did a great job. Thanks for the introduction, Scott.
All right. So I think we'll probably just jump in and to our slideshow here. So before I really get started, I just wanted to say that you can interrupt me at any time with questions in the chat. I'd really appreciate if someone was monitoring that, because I'll probably not be able to see that as I'm doing that. So questions at any time are welcome. You're not going to throw me off. I'd love that discourse. So that would be great. And hopefully with that, the stuff we're going to be talking about today is really bizarre, a lot of it. So and hopefully fun. Let's see if I can actually get this started. So Alex and I are two members of a pretty big team at the SEGS lab. We've got a number of graduate students and undergrads and postdocs and technicians and everything working on trying to understand a bunch of different social ecological problems. So any sort of thing like climate change or anything else like health related stuff that's dealing with the ecology and society, we're probably interested. Today, we're going to be doing a lot with precision ag. So the stuff we're going to be talking about today is supported by the USDA and National Science Foundation. And I wanted to put a shout out to the Agrotech Summer Academy. We're going to be presenting as one group or out of three. And I think it's going to be a really, really cool experience. This is a free week-long experience at the University of Vermont. You can come check out what it's like to be a college student and do research and come out with a product. And I think it's going to be a really cool environment if you have a chance to do this. Just really briefly, there's these three academies. They're all a week long. They're all free. You stay at UVM. One's this culturing cells for healthier soils. One's looking at changing the way we think about waste. And ours is looking at precision agriculture, not just necessarily with virtual reality, but also augmented reality, perhaps, or using some really cool gaming software for learning how to develop your own games and create your own precision agricultural world at your farm or other location that you want to make. So hopefully we'll have a lot of fun with that. And you don't have to know anything about coding beforehand. We're going to take you through the process one step at a time. So you'll get a chance to really learn. This is June 25th to June 30th. And then there's some other follow-up things that are going on throughout the summer. And really will give you a chance to see what it's like to be around here and have some fun. Applications are open right now. So if you're interested, go ahead and apply. And if you have any questions at all, Sarah Kleiman has, I'm sure, all of the answers. She's on the call, so I'm just going to put her on the spot, but she has every answer for every question. So go ahead and email her if you're interested. So this is what we have as what we are. This is the Social Ecological Gaming and Simulation Lab. Is a transdisciplinary research lab focused on modeling and simulating social ecological systems from a complex systems perspective. How is that for a mouthful? Basically, what we're doing is we're trying to understand how humans respond to different kinds of conflict. And we put people into different situations and see what happens. A lot of this is through gaming. We create games and put them into a context and see how they respond. We do some simulation work, we do some survey work, we do develop some applications, a number of different things. We're supported by a lot of different people, including the USDA and NSF, like I've already mentioned, but NOAA and the National Weather Service are asking us to help out with learning how to communicate with flood hazards. Robert Wood Johnson Foundation is helping us look at some of the problems with trying to get good foods to socio-economically challenged individuals. So we have research all over the place. I already mentioned some of these things. What our process is to try to talk to the people that it's really impacting through workshops, interviews, that sort of thing. And then start diving deeper with some surveys or serious games to try to learn how to help people through these really challenging problems. Like the one we're dealing with today is how do we get people to kind of engage with precision agriculture, which could have some real win-wins for the environment and for farmers. Other ones we're doing, like how do we stop people from dying in floods? So we're trying to tackle some pretty big problems in communication and understanding with risk. As I mentioned, one of the things we do is games, which is kind of a weird thing to think about games as a research tool. But we use these serious games to try to understand how people behave. All right, first question. Anybody play video games? Alex and I were talking about that earlier. The chat is flying here. I was saying basically my favorite game was kind of like this role-playing game style thing where you can develop a player and that sort of thing. And these are some of the more popular ones. But I want you to think about, like, when you're playing these games, board games, poker, whatever else it is, you kind of get the feeling that, you can see how certain people play. Like there's that really aggressive person or that really person that just never likes to take any chances. It's kind of this thing you can actually, I love this. Galaga is fantastic. I love that, Lauren. The way people engage with games, there's very different kind of almost personalities. And sometimes those are reflected in the way they are in the real world, and sometimes it's a little different. Scott Lewins is on. Welcome, Scott. Nintendo Sports. Yes, that is a fun one. I've been playing that as well. I'm really bad at it. So let's see if I can keep this going here. So think about when you're playing in a group. Are there people out there that are like, they're doing things in a different way than others, and you can actually start picking up on some of these personalities. Now, here's a question. What do you think? Do you think if there was more at stake, if these games really, really mattered, would people play differently? Think about that for a second. If you had, say, tons of money or a friendship on the line or some other, like a reputation, do you think you'd play differently with this game than you would otherwise? So what we're trying to do is we're trying to get as close to how people would actually behave in a situation as possible. And that's actually pretty challenging. There's a lot of problems with trying to gather data. A lot of people will use surveys. A lot of people use interviews. A lot of people use, focus groups, different things to try to understand human behavior. But that's not very easy. I love this cartoon, by the way. Yes. After 50 survey questions, I do feel like killing someone. All right, so we're gonna try a little thing here. If your house is on fire, this is an interview. Now you're being interviewed by somebody across the room from you. They're asking you to respond pretty quickly. The interviewer says, your house is on fire. You've got a chance, you've got two hands. You can grab two things on the way out of the house. What are you gonna grab? This heirloom necklace from your grandma, $15,000, or your laptop, all your photos, your phone, your pet goldfish, or a painting that you don't really like, but it's really worth a lot of money. Okay, so you think about this, as somebody's looking at you and you're well, I want my phone and my laptop, but they're judging you if you don't get your goldfish. You're just going to let your goldfish burn up. So you might not answer the way you'd actually respond if you're being interviewed by somebody, for fear that they might judge you in some way. But you might respond differently if it was just a piece of paper and it was anonymous, right? Same things. If it was anonymous, you might answer this one a little differently when you have time to just think about it, and you're not on the spot, not feeling like you're judged as much. But how does that relate to if your house was actually on fire? Obviously you grab your phone, but would you grab your laptop? Your house is on fire. Maybe you just run away. I mean, what? Yeah, I mean, this is one of those things that, grab that photo book, or you just grab something random because it's next to your door. So we can learn potentially a lot by using games to kind of simulate that environment. It might get it a little closer to how people would really respond. But this is a crazy one. World of Warcraft, this happened a while back, obviously. But at the time, World of Warcraft was still a pretty big online game with about 2 million people playing. And this dungeon, basically, this kind of side thing, had a crazy creature that could poison players. And that plague basically got out of control because the non-player characters, these pets, could get the disease. And that was able to escape the dungeon, this side thing, and get out into the world with these 2 million players. And suddenly you had a plague going on. And people were responding in really interesting ways and in fairly realistic ways. A lot of them just tried to get away from the plague, tried to get away from people. Other people went in to help. Some people pretended like it wasn't a thing. And other people were like, oh, I'm just going to get all these, these things from the bodies laying in the streets. So it was to the point where they actually had to shut down the game and reset it on the servers, which was a huge deal because they couldn't figure out how to get it back under control. So they actually wrote scientific articles about this because it was such a large audience and it was such a variety of distributions of behavior that they were able to try to understand how people might respond in a real world epidemic. Interestingly, they actually tried to warn people about what would happen in something like COVID, and say, that this is the distribution of behaviors we might actually see if there was a real outbreak of something. And it was different than a lot of the planners had said, but actually matched up really well with actual behavior. Fascinating stuff that we can learn from games. 2 million people is probably more than we get. We usually get about 1,000 people playing our games. So one problem we've already hinted at is, how do you get people to play when there's nothing on the line? There was this game in California that they're trying to teach high school students how to eat properly. And they had an avatar that they were taking care of. And if they ate really well, the avatar looked healthy, that sort of thing. But somebody figured out if you didn't eat any fruits or vegetables, you could get scurvy. Any guesses as to what happened? Everybody went and tried to get scurvy. Your teeth are falling out, your avatar is not looking good. And the reason is because they didn't say why they shouldn't do this. I mean, it's not them, it's just their avatar, right? So what do you think would happen if, instead of just having this as a interesting thing of learning, we said, okay, well, if your avatar stays healthy, we're going to give you $100 at the end of the week? How many people do you think would actually go get scurvy, or $200 or $1,000? So we actually, when people play our games to get people to really engage and not just click buttons, we actually pay them based on how well they play. So that's a way around some of those things. We increase the stakes a little so that people play more reasonably. So we have a lot of these games, a lot of these simulations trying to understand human behavior and nudge that behavior in a way that helps most people out. These are a way of actually testing decision-making. And we can test a bunch of messages to see which way works the best. We can try out a bunch of scenarios to see how people respond so that, say, emergency responders can give an idea of what kind of things they might be confronted with. Just to give you a really quick one, we did a COVID game, and we're looking at their people's willingness to break that social distancing rule. In this game, we had people go decide whether or not they're going to go to a grocery store, given the infection in the community at the time, and they had to get groceries at the grocery store. And there was a bunch of people in there we had running around with them. Some of them masked, some of them unmasked. And we wanted to see what influenced them to try to get a lot of groceries or not a lot of groceries. We also, beforehand, asked them a bunch of questions about how risky different activities, they felt different activities were for actually acquiring COVID in a bunch of survey questions. And what we found, which was really interesting, is that the people that generally thought most activities were safe and they weren't probably going to get COVID, things like gathering in large groups, or going to a indoor party, or going grocery shopping, or going outside to get exercise, all these sorts of things. The people that said, I'm probably safe, they broke the social distancing a lot more than those that thought it was really risky to do all those things. Fascinating stuff. So the people that actually felt a certain way in the real world behave differently in the virtual world. What that means is then we can test messages to see how to influence those people to behave in a way that probably is better for not spreading the disease. We can also say, okay, well, if people behave this way, what happens? So we can actually create a simulation of an entire system and put in, okay, if everybody acted like these people, what would happen? What if we had everybody else acting like this other way? How would the disease change? We actually did that with a biosecurity project where we're looking at animal behavior. Sorry, not animal behavior, animal disease. So we're looking at the spread of disease in livestock. And we actually clustered these individuals by how willing to take risks they were in these environments or not. And saw some really fascinating things where if we had everybody as risk takers, the disease sometimes just petered out. But sometimes it was massive, which is kind of really insightful. It's like sometimes people were taking all sorts of risks out there and they were staying safe. And other times, little communities would just get hammered. So we actually saw that reflected in this sort of livestock world as well. So we actually mapped our results to real world livestock epidemics, and then saw how it might have changed if we had people really following the rules and really doing a good job at trying to keep the animals safe, and the distributions of those, and see how it might be able to help the system overall so that the next time something happens, that it might be a little more resilient and less animals would get sick. So we do a lot in the lab. Some of these things are games. Some of these things are models. We do the survey work. We do focus groups. We also do some stuff with creating apps. I'm guessing that most of you recognize the two apps on the left there. It's hard to imagine a time when you didn't have Google Maps at your fingertips. There was a time when we actually used paper maps. This may have been before any of you were ever born. I don't know if you've ever seen a paper map. But it's pretty funny when I was like, okay, where's my phone? I don't know how to get anywhere. It's like, oh, right. I could actually figure this out in other ways. I haven't always had this Google Maps app on my phone. Personally, I love
Tried it
Duolingo.
once.
What's that, Alex?
Tried following a paper map once, and it's harder than I thought.
It's a skill. There you go, Lauren. An entire cross-country road trip on a paper map. We actually brought on a recent cross-country thing. We brought an atlas and put markers on where we'd been. But for the planning purposes, we use Google Maps. I'm trying to figure out where we're going. I mean, you have to know where Starbucks is, right? I mean, it's critical, and that's just not on the map.
Exactly.
So one of our apps we're currently making is trying to help farmers plan some of this biosecurity stuff. If disease hits, it's really important for them to have knowledge of where things are on their farm and how to keep things safe. So one of the pieces is developing a map so that they know, and emergency responders know where things are. And so we're helping the National Pork Board and Secure Milk Supply and some others develop mapping applications to allow them to have the farmers, each of the farmers or each of these facilities map out where things are. Also doing things with the Office of Engagement and some climate work, trying to figure out where temperatures are going to be in 50 years, given different forcing patterns. So we do a lot with this app side as well. These are more outreach projects. So we're not really collecting data from these. It's more like trying to help the people that need help in different ways. We're working on a lot of different projects. I've mentioned some of them. I'm not going to spend a lot of time on here. A big one that I want to talk to you about today is this idea of using precision agriculture and possibly think about artificial intelligence and how that might actually come into play. It's just a hint of things that are about ready to come here. So what is precision ag? Precision agriculture is a way of farming that uses technology, a lot of spatial technology to help farmers grow more crops. It's not just using more crops, but it's also like optimizing different ways of growing things. You can change things like your fertilizer or seeding rate or where you're spraying pesticides. But the key word in that last sentence is where. So this is a lot of spatial information goes into this idea of precision ag. So you can figure out when to plant, where to plant, how much to plant, what controls to use, what management decisions. And that's one of those things that if we can actually use some of the information that's out there, that the field is not one unit, that there's differences across your field, we can really improve yields and we can reduce harmful things that are going on. Say if you put too much nutrients onto an area and it washed off into the waterways. So one of the projects I worked on ages ago, we separated the field, a cornfield that we were working on, into kind of 3 bins. One was a bin that was high yield. So that was kind of our crop land that was really producing a lot and worth more money. And then there was a medium yield, and that was kind of like your medium money. And then there was low yield, which we typically didn't get a lot of corn out of. So that we didn't make very much money on that area. And what I was looking at is whether or not we wanted to think about treating pests in those different areas differently. Because there's a high value area and there's a low value area, and it costs money to do these things, and it has a lot of environmental repercussions as well. So you could think about this from a pest perspective. You could think about this from a fertilizer perspective. You could think about this from how much seed you put out there or what kind of crop goes in which area. All those things are kind of precision agriculture. So where does this idea of artificial intelligence come into play? And this is an interesting one. So artificial intelligence is kind of creeping into a lot of different things. And I was talking to Alex about this earlier today. So questions for the chat. On a scale of 1, completely distrust, to 10, you'd sign over your life to an AI. How much do you trust AI? 5. Okay, real middle of the road.
Ooh, a
Whoa,
10.
sign over your life. Andrew, that's risky.
Oh my. Ready to get an implant in your brain. Andrew is.
I like it, Andrew. Okay, all right. I would say that I'm close to a 7. Alex, you're a little higher.
Yeah, I'm at 7.5, 8 maybe. I'm pretty trusting of AI.
So what surprised me is, and I'll get into this in a second. Okay, the next question. How often do you think you use it? On a, is it maybe a daily thing, or is it a weekly? Never used AI?
I'm interested to see what people say. Right now in the Zoom chat. Yeah. I'll betcha. Daily, yep.
Yep.
Probably more than I realized. That is a intelligent answer. I like
Yes, yes. So
the realm of what we know and what we know we know and what we don't know we don't know.
yes. So Alex just started listing off earlier all the things that use AI. And like Ken just said, it's everywhere. I mean, it's in all the things that we're doing. Do you want to, Alex, what were some of the things?
Oh, I was just going down the list. I mean, so many companies, it's a part of all of their systems. If you use social media, all of those apps have algorithms that you're passively using. If you ever Google something, they're using an AI algorithm. If you walk into like one of the big name brand grocery stores, they'll have optimized layout of all of the products and food in the store using one of their AI algorithms. So it's really just everywhere that we see. It's only going to be used more as it gets more advanced and more complex.
All right. And here's one that just came out November. Who here has heard of Chat GPT? Who here has used it? So personally, Chat GPT. Yeah, God, that's a little frightening, but yes. Yeah. I mean, it is truly an amazing and terrifying thing. So Chat GPT is a produces language, produces code. So Misha, do you use it for like I mean, I think it's fun too, but do you use it for like coding or how's it fun?
Yeah, I think ChatGPT being this is only the beginning. Like there's going to be a GPT-3, or this is GPT-3. There's going to be a GPT-4, and ChatGPT, if you think what it can do now is impressive, it's gonna be
So
more powerful.
I think it's really fun, and it's kind of depressing at times, I think, Misha, because it is fun, but then you're like, wow, that's better than I could do. And it kind of takes the wind out of you a couple times. So so it it does a lot. Obviously, many of you have heard of it. It does a lot with language creation. And so I was like, okay, so how should I introduce precision agriculture earlier? And it came up with this, which I thought was actually really, really good. It talks about the pros and the cons. And I do think it is important to think, the pros with precision ag, that it can help with a lot of things. It can help optimize yield. It can help reduce nutrient runoff and environmental harms. It can be expensive though, and it can be pretty complex at times. So you need to have really good communication, I think, to make sure that people understand how it can benefit them and whatnot. One of the things in precision agriculture that we're trying to do is use an AI to make the models that recommend what to do better. So that's how we're trying to positively use AI in some of our work. And that kind of brings to this what we're trying to do with some of the agrotech in the Summer Academy, is we're trying to open the door so people that will start trusting in the ideas in precision ag, and then potentially, trust some advice that an AI would give to where you might want to plant and what kind of fertilizer loads you might want to put on, or whether or not you should spray pesticides, or plant a buffer strip in a certain area to reduce the negative impacts from runoff from your land. So we're trying to open the door to the use of precision agriculture. And the way we're doing that, and what we're going to do with agrotech, is by combining a lot of the tools that we already are developing. And Alex is going to go into this in just a moment, but trying to encapsulate some of these ideas and some of the gaming technology, as well as some of the app technology, to build a really cool product that people can use and enjoy. So I think I'm going to stop sharing and let Alex take over and explain some of the mapping applications that have already been developed for precision ag, as well as what we're going in the future.
Great. Let me just get the screen shared up here. Share screen one. Shared that. All right. All right. So here is one of the tools that we've adapted in the SEGS lab. I'll share the link to this so you can kind of play along if you want while I explain how to use it. I want to put this in the chat. Let's see, where did the chat go? Where is this chat? As soon as I start, oh, there it is. It's at the top. We hide it. All right, so here on the home screen, we can quick go to the tutorial farm. It'll bring us to the UVM horticultural farm. If you're using it in a private browsing tab right now on our servers at UVM, if you just open it in a normal internet browser, it'll bring you to a different location than what you see here, because the servers are sometimes a little slow to update our changes. But anyways, this is the UVM horticultural farm. And this application is designed for us to be able to mark out zones and that denote different zones on our farms for various purposes. So we give a couple of default options down here for just marking the yield of zones. So for instance, we want to mark a field as a high yield field. We can select high yield up here. Then we just click on the map to draw a point, click wherever we want the second point, and so on, and it'll create a polygon. So this is now designated as a high yield field, and maybe the rest of the field is going to be low yield.
And this information can come
default,
from personal experience. It could come from, your crop advisor saying, this is really, where things have gone in the past, and you might want to, your soil is really good here and you need to utilize that. So this advice could come from anywhere, but we're thinking right now, it's probably like your personal belief on what the high yield might be. Sorry, Alex, to interrupt.
Yeah. No, that's exactly right. So this isn't implementing any of the tool isn't analyzing your farm initially for you with this application, which we'll get into in a little bit. But this is more so it's an easy tool that a farmer can put in the address of their own farm like they would in Google Maps, but then also make the map more readable to themselves in a way, and designate zones, and maybe like we can do points of where a tractor would start on the field, and track what they know about their fields in a way that is more easily viewable. If you also want to create your own features, because these are just the base features we thought would be pretty useful for most, but say I want to add a zone for pesticide. We can create a custom layer. And we'll select the zone. Maybe we'll make it a green. And we can create that layer. It gets added to the legend. Then we'll select it and say, all right, we got to apply pesticide to this section of the field. So in that way, the farmers can use this map to better understand their own fields. But it does have a couple of limitations. This is using OpenStreetMaps data to get the satellite imagery. And as you can tell, it's all in 2D. And we would like if we could get a little bit more detail about the farms than just this overhead view. So a kind of intermediary solution that we have been working with is using Google Earth Pro. And so you'll see this is the same farm, the Horticultural Research Center farm. But here in Google Earth Pro, which is an out-of-the-box tool that you can download, we can take advantage of the better data that Google has, where it has its Landsat and Copernicus data sets. And that'll allow us to get into a lot more detail, including 3D detail. So here, as I zoom in, we'll be able to see the height for some of the crops. You can see the height of buildings, cars, other features on the map. So you get a lot more perspective, a little too much details. Let me zoom out there. And
so that
additionally,
tree just blew down recently, so it shouldn't be on the Google Maps anyway. In addition, like it can perform a lot of the features that our mapping application can at this time. Like if I want to make a point on this map, say this looks like a rock or something that needs to be removed. I'll lay down my point and mark it. Or if I want to make a polygon and go ahead and make the same kind of yield diagrams on here, I can draw out my polygon, title it. We can style it how we want. This seems like a good styling. We'll select it. You can also add a label on the map if you want. But the nice thing about this view is that it's easier to get some details that we wouldn't otherwise have access to in the 2D version. Like it seems to me that this field is a bit of a, especially if we see it from here, I think it's sloping down, which might help us identify
or get some intuition for like drainage. Maybe the water's draining down this direction. So we maybe want to put like a buffer strip somewhere on this side of the field to catch that runoff. But again, this is kind of an intermediary step because it's a limited application, as we did not fully develop this application. So if we want to customize it more, we have to take this data that Google Earth is using and bring it in to another application and make it into one of our games. So right now we're thinking of using probably Unity and maybe some combination of Unity and Google Earth Engine, which is the API for dealing with data from Google Earth, to handle this data that Google Earth has, the more precise 3D maps that they have. And that would allow us to have a couple of different features that we're not able to do in just this application or on our online map app. For instance, if you want to do a vegetation index where you look at, okay, you analyze the data from year to year for how many crops you had, or the yield of crops based on the satellite imagery. So there's tools that you can get an index of, okay, this year there was this percentage of, it kind of looks at the image and takes out the greenness, for instance, and a couple other features of the image. And it says compared to 2006.
Did we just lose Alex? I think we might have lost Alex there.
Yeah, that froze for me, but I can
Okay.
hear you just fine.
All right. So what Alex was saying with these vegetation indexes, if you had many years of data, that you could actually combine those and say, oh, it looks like there's some, this area of the field always yields more than this area of the field. And we can actually use that information in the Unity world or the Google Earth Engine world in ways that are a little different. Alex, it looks like you're back, but you froze there for a little while.
Yeah, sorry about that. How long did I freeze for? I apologize.
Not too long. Not too long. It was
Okay.
just that you're talking about the vegetation indexes, and then I kind of continued through that.
Okay.
So,
thank you for picking that up for me.
Yeah.
I don't know what happened there.
So you can go ahead and tell them, I guess, with
Yeah,
the academy.
I'll continue talking a little. Yeah. So our hope for over the summer is to basically bring in a bunch of junior developers, people who are interested both in games, making their own games, and helping out potentially if their family has a farm or if they want to really learn more about the different applications for mapping or improving their farms, and kind of combine all of these things into one like fun learning experience, where we expect that they can learn from a couple different things. We'd probably want to, what do you think, Scott? Introduce the Unity tools as in basics before we get into more of the specifics of these like precision agriculture games. So it'd be a little bit of coding at the beginning, probably a little bit of getting familiar with that and the other projects in the SEGS lab.
So the Unity engine is actually a really fun thing to play with. It is what is used. The Unity engine is used on a lot of the big games that you've heard of. Pokemon Go created in Unity. It is the engine that we use for creating all of our serious games. And
I guess we should probably say what an engine is.
Oh yeah.
I should. So a game engine is basically an environment that simulates the physics of or that can simulate different types of physics and the physics of like a real world environment. So it makes it easy for when you're having games or simulations to like emulate that real world, like what would it be like to interact with an object.
So I think our overall goal is to create or have each person that's in the academy actually be able to come in and create a virtual world of their particular farm, and have all the kind of the management features for precision ag if they want it. And then they could take that home with them and say, okay, look, we can fly through this environment. We can walk through this environment in kind of in a first person thing. And does that help you visualize what this farm would look like if we changed the management strategy to this or that, or if we thought about just doing different rates of fertilizer on this area than that area? And it's their own farm. It's a virtual world. If we are really successful, it's pretty easy in Unity to develop augmented reality and virtual reality. That is kind of an advanced step. So we have to see how the week goes. But those are possibilities in Unity. It wasn't too long ago that I spent way too much time creating a virtual reality bowling game in a crazy environment, because I was just like, okay, this is just so much fun. And then it was like 3 a.m. I'm like, I've got to go to bed. I've got to work in the morning. So it was pretty bad to start playing with Unity because it's too much fun. But
yeah, it's got that potential to go, you can bring your game either on your desktop, and you can also port it to your phone really easily, which is another nice thing about Unity.
Yes, so that is kind of the next steps, and what we hope to have people learn about and get exposed to with the Summer Academy. Really excited about that. Really excited about building a tool that will open the doors to people learning about precision agriculture and using precision agriculture, and then having that model that provides some really good advice on what precision agricultural tools they might want to implement to really optimize their landscape for whatever goals that they personally have.
Yeah, and Sarah, I just saw your question. Can people who don't live on farms or are farm connected participate in this academy? And definitely, of course, we can use anybody's farm. Really, it would be cool if you have your own, just because that is a little bit more personalized or feels personalized when you're developing your product. But yeah, you do not need to have your own farm to participate.
Yeah, I mean, in fact, I mean, if you grew up in the city like I did, you could go play around in your old neighborhood and you could make your putt golf course on top of your roof, whatever it is. And this is the type of tool that can be used in a lot of different ways.
We have 6 minutes left. Do we want to have some questions?
Yeah, I wanted to see if there was any other things on my. Okay, let me just go through here. I think this is not working for me. Sorry, I'm gonna stop sharing and go back to that. But I encourage people, if they're interested, to go back to that early slide and apply to the Summer Academy and ask Sarah lots of questions if you're interested. Yeah.
See if I can find that link for the chat.
Yes, go ahead and ask us any questions that you'd like. You could ask about flooding. We're going to try to develop, with the National Weather Service and NOAA, a game that helps with flooding as well, and some apps that help with flooding and communication, and try to help save some infrastructure and some lives. We're doing all this with the same kind of ideas that we presented today, and you can probably see how that would work. If we have some maps of landscapes, we allow people to manipulate that and say, okay, well, what if we did this here? What if we did this there? And open some doors to conversations. And we can also like simulate floods That's something that we're working on right now, is like, if we have a simulated flood, what happens here? What happens to your farm if we have a rainstorm right up the street and it gets flooded? So is there something you want to do differently?
Thanks for putting that link in the chat, Sarah.
And while you all are thinking if you might have a question for our guests here, I am going to just pop up a quick poll. We like to just get some feedback. And the question tonight is, on a scale of 1 to 5, did you learn something tonight from Scott and Alex? So 5 if you learned a lot, and then on down.
I like this so far.
And then, of course, you can put any comments in the chat. But I do see that Andrew has a question. Is there a local farm that you are using as a case study?
So a lot of our tutorials are going to be based on Vermont horticulture farm. But I wouldn't say that that's really critical to what we're doing. A lot of the so the flooding, the first flood game is going to be in Waterbury. The National Pork Board app that we're developing has a farm in Virginia that we're using. We're also using a local farm here, do some of the milk stuff, the precision ag stuff. We have 10 farms in South Dakota and 10 farms in Vermont and 2 farms, I think, in Virginia, or something along those lines, that we're using, and we're heavily monitoring and using drones and stuff to fly over them and try to get as much sensory data as we can to help with our development of our precision agricultural AI. And so we have ground sensors and soil sensors and stuff like that. So it's for the precision agriculture product or project with the National Science Foundation. It's using a lot of different farms. Is that kind of what you're getting at, Andrew?
All right, we have about 2 minutes remaining. Any questions about their work in the SEGS lab, or what else you might do during the summer academy besides doing some cool coding? Will there be any farm visits to see like the precision agriculture like in action?
We hadn't gotten that far. That's a great question. With this project, we could actually probably go to one of these places, but I also felt like there was so much that we could do in the virtual world. If they're trying to learn, all these different pieces, that the excitement might be learning the science and how we actually gather data and why it's important, and then the gaming world and that environment is there as well. So I don't want to overpromise that we'll do things on these farms that have been highly sensed, with sensors all over the place and the drone flybys and the satellite imagery.
Tomorrow night. I'm not cooking tomorrow.
Yeah, I mean, there's just could be a ton.
Or we can have it for lunch and have a.
How long have you guys been studying these farms?
So the precision ag farms that we're using in Vermont are a big part of Stone Environmentals. They've been doing some work there, and they've been doing that, I think, for a handful of years now. So they've got some background with different management practices and how it affects things like soils and whatnot. The South Dakota farms they don't have that history. So we've just been starting this, I'd say probably only about a year of data collection. So it depends on where. Yeah, I mean, the cool thing about the Stone Environmental, the Vermont sites, Aaron, is that we're trying things like we'll do one split field. So one half of the field will be managed one way and one half of the field will be managed the other way. And we'll see what kind of nutrient runoff we have in those different situations. So that you can be like, oh, look, if you do reduced tillage, you're saving water quality. You're not getting as many algal blooms in the lake. So there's a lot that we could potentially do with this idea of splitting up the field and trying different things out.
Do you see Andrew had a question in the chat? What's your best example of how modeling has created real world results?
Whoa. So, best example. I think the example that I like the most, I'm trained as an ecologist, and back in the 70s, I think it was started in the 70s, maybe even the 60s. There was a pesticide called DDT. We've probably heard of it. That looked like it was a fantastic pesticide. It did not do any damage to humans. Humans could be around it a lot. There was no carcinogenic, or it didn't cause cancer, nothing like that. It looked really great. And so a lot of people started using it. And there was this idea that came out, or what people started seeing was that bald eagles, peregrine falcons, a lot of the critical kind of apex bird predators were starting to really die off. And someone created a model that suggested that it might be because of something called bioaccumulation. The insects that were actually taking in the DDT were being eaten by fish, and then the fish were being eaten by other things, like the eagles, and this pesticide kept on accumulating in the animals that it was eating as it went up the food chain, to the point where there was a fair amount in the bald eagle. Now, it didn't hurt the bald eagle or the peregrine falcon, but it made their shells weak. So when they were actually laying their eggs, they were crushing their own eggs if there was a lot of DDT in the area. And that was all through kind of modeling work. Somebody statistically figured out this and modeled it through the whole chain to see what the end results would be. And they figured out they really needed to cut out DDT if we wanted to have bald eagles anymore, if we wanted to have peregrine falcons, the fastest animal on the planet anymore. So I thought that was it's a really cool example of, to me, the impact of modeling. But that was almost more of a statistical model. There's some of these really complex agent-based models or something like that have some really show some bizarre and cool, fascinating things. But I don't have a great example of that one.
Well, I'm going to encourage Andrew to sign up for the Academy, and then he can pick your brain for an entire week this summer. Unfortunately, we are over our time tonight. I want to thank you all for coming. Let's thank Scott and Alex for sharing their work with us, hopefully getting some of you excited about applying for the Agrotech Summer Academy, specifically the one that they are leading. And again, if you have any questions about the program this summer, just click on that link that was provided in the chat to learn more about the program, and then you can ask any questions to Sarah Kleinman if there's something that you need to ask. But thank you all for coming, and hopefully we'll see you at the next in-person Science Cafe. So thank you all.
Andrew, one last thing.